Welcome to Exponential Equations Part 2, and you can see I've got just a lovely example sitting here. We're going to try to solve for x. So, where do we begin? Well, I look at these bases, 8, 16, 32, and you know what springs out is, hey, can't I rewrite each of these numbers as powers of 2? And actually, you can, and that's the key. So as miserable as this is, I can write this as 2 cubed, all raised to the x plus 6. Okay, and that's all over 2 to the 4th raised to the 2x minus 1. And then over here, 32, I'm going to write that as 2 to the 5th raised to the 3x minus 4. All right, so that's step one. I can see I'm going to end up with the same bases, but I do have a little bit of extra work to do. So let's see. I might not be able to fit it all in one page here. But anyway, let's see what we can do. Okay, so here's my fraction. And on the top, the inner and outer exponents, I'm going to have 2 to the 3 times x plus 6. So this will be 2 to the 3x plus 18. And underneath it, I'm going to have 2 to the 8x minus 4. All right, and over on this side, I'm going to have 2 to the 5 times 3x, so that's 15x, and then minus 20. All right. Okay, this one has one little added twist, and that is over here, I still got to process this mess. How do I process this mess? Well, let's see. Maybe I can clear off part of this screen, and then I can just work with that still there. Yeah, I think I can. Okay, so here's what I do. When you are dividing powers, which I'm doing, and they have the same base, the rule is you can just subtract your exponents. So I'm going to have 3x plus 18, and then I'm going to go minus the exponent on the bottom, which is the 8x minus 4. Okay, and now I can say that still does equal 2 to the 15x minus 20. Okay, so again, I've got this power divided by this power, so I'm just subtracting my two exponents. So that's where this mess comes from here. Well, I now have 2 to the something equals 2 to the something else. So I'm going to dispense these 2's out of the picture. In fact, I'm even going to put a little separator there and say, you know, let's just work with these exponents now. 3x plus 18. And then let's get rid of these brackets here. That would be minus 8x. And then this would become plus 4. And this would have to equal 15x minus 20. So let's get all the x's on one side. So let's see, what do we got here? We got, looks like negative 5x's. So why don't we add 5x's to this side? So that's 20x's. And then I'm going to add the 20 over to these numbers. And what we got here, it looks like 22. If I add 20 to that, would be, let's see, 42. And then lastly, if I divide by 20, I have solved for x. So this is going to turn out to be 2.1. And there it is, ladies and gentlemen. We have solved this misery for x. All right, I have one last example, and then we're going to move on to other exciting topics. So let's clear off the screen. And here's what we're going to try to solve this time. We've got 4 raised to the x. Starts off simple enough, and then we've got this, 16 times the cube root of 4. So I go, oh my goodness, what am I going to do with this mess? All right. Well, I think the key to this is you look at this and you go, well, this is a base 4. It's a power with 4 as its base. So that kind of tells me I want to try to work the right side so it's all base 4 kind of stuff. So right off the bat, why don't we rewrite 16 as 4 squared? Okay, again, I'm thinking base 4 here. And what about this cube root of 4 business? Well, you can write that as 4 to the 1/3. Okay, that's the same as the cube root of 4. So let's see what we got here now. We got 4 to the x equals, and here, if I'm multiplying these two powers together and they have the same base, the rule is I add my exponents. And you know what? I'm going to leave them as a mixed number. 2 plus 1/3 is like 2 1/3. And look at this. It's so easy now to just look at it and say, well then x here must equal 2 1/3. And that's all there is to it. And that's where I'm going to stop for now. We'll catch you later.